Hello and welcome to my channel. This is question number 16 of the IIT JAM Mathematics 2025 question paper, section A, 2 marks. It is based on eigenvalues and eigenvectors. Let us get started. So once again, we are having a matrix M and it has an unknown x, which is some real number. And it is stated that negative 2 and 3 are eigenvalues of M if m cube times the vector 0, 1, 1 is equal to the vector 0, 1, 2, 5 and 1, 2, 5, then which of the following is true? And we have got 4 options. It is worth noting that we have x equals to 5 and x does not equals 5 in all the 4 options. And then we have the other half to check whether m square plus m is invertible or it is not. So thus we have 2 parts to check. One is the value of x, if it is 5 or not 5. And the other one is whether the matrix m square plus m is invertible. So our first objective is going to be to find out the value of x, and for that we are going to use the eigenvalues and its properties. So again, since M is a 3 by 3 matrix, we know that there will be 3 eigenvalues. So call it lambda 1, lambda 2 and lambda 3. And let us say that lambda 1 is negative 2 and lambda 2 is 3. Lambda 3 is unknown that we wish to determine. Also, we know that the product of the eigenvalue is equal to the determinant of the matrix, while the sum of the eigenvalues is equal to the trace of the matrix. So we have the product of the 3 eigenvalues to be negative 6 lambda 3, and the determinant is going to be from here. So we'll start with negative 2. So negative 2 times of 2x plus 3, which simplifies to negative 6 lambda cube is equal to negative 4x negative 6, and this gives us that 4x minus 6 lambda 3 is equal to negative 6. Now since there are 2 unknowns involved, we expect to get another equation and solve it simultaneously. So let me mark this as equation number 1. To find the other equation, we are going to use the sum property of the eigenvalues, and thus we get that the sum, which is minus 2 plus 3, that is 1 plus lambda 3, should be equal to the trace, that is negative 2 plus x, which is x. And from here we get that negative x plus lambda 3 is equal to negative 1. If I try to equate the coefficients, then here we can see that the coefficient of x is 4 and here it is negative 1. So let me multiply it by 4. So I'll have negative 4x plus 4 lambda 3 is equal to negative 4. Now let's add equation number 1 and 2. So after adding equation 1 and 2, we get rid of the x term, and here we'll be left out with negative 2 lambda cube is equal to negative 10, which gives us that lambda 3 is equal to 5. Thus the third eigenvalue is 5. Now substituting this in any of the 2 equations, we will be getting the value of x. For keeping it simple, let me substitute in this expression with smaller coefficients. So we get minus x plus lambda 3, which is 5, is equal to negative 1, and therefore we have negative x is equal to negative 6, which gives us that x is equal to 6. So thus we have got the value of x to be 6, and we can look up at the options now. In option A, it says that x is equal to 5, so we are sure that this is false. In option C also x equals 5, so we are sure that this is also false. Now moving to the next part, we will be just trying at identifying whether m square plus m is invertible or not. Now for that we are again going to stick back to a simple property. For invertibility, we are aware that a matrix A is invertible if and only if its determinant is not equal to 0, and we know that the determinant of a matrix is nothing but the product of eigenvalues. So we are going to find the eigenvalues for m square plus m, and then we are going to take the product and check if it is going to be 0. Now the eigenvalues for m square plus m are going to be lambda 1 square plus lambda, lambda 2 square plus lambda, and lambda 3 square plus lambda. Lambda 1 square plus lambda 1 is going to be negative 2 square plus negative 2, which is not 0. Then lambda 2 square plus lambda 2 is going to be 3 square plus 3. That's again not a 0 number. And lambda 3 square plus lambda 3 is going to be 5 square plus 5. That is again a non-zero number. So thus we have that all three eigenvalues of m square plus m are non-zero, and hence the product of these eigenvalue will also be non-zero. And with that we can finally conclude that m square plus m is going to be an invertible matrix. Thus one can conclude that option B is the correct one. If you find this video helpful, then press the like button and also share it with your friends who are preparing for competitive examinations in mathematics. Also, do subscribe my channel and do not forget to press the bell notification to keep updated. Thank you so much for watching and happy learning.